we want to do a brief review of exponential functions and their graphs. An exponential function is something in the form of f of x is equal to a to the x, where a is a number greater than 0 and not equal to 1. So something like y equals 2 to the x. You don't want this to be a 1 because 1 to the x would be just y is equal to 1, no matter what you put in for x. So you would just get a horizontal line, not an exponential function. And then our exponent x can be any real number, so just not an imaginary, any real number. So we can start by throwing some of these into our calculator, and we'll just type them straight in. So grab your graphing calculator if you would, please. All right, so we've got 2, and of course when I type something it lights up in red on my calculator. So 2 to the negative, and be sure that you use your negative and not your subtraction key. So this is my subtraction key, this is my negative. See the difference? And it'll give me a syntax error if I use the negative. If I use the subtraction sign instead of the negative. All right, so negative 3.1, and then we had 2 to the negative pi, and pi on your calculator is right here. Again, you can see it in red, so I had to hit second and then that button to access the second option of pi. And then 12 to the 5/7, and then 0.6 to the 3/2. So again, we can just type those straight in, and so that's where we are getting these values that you're seeing here. We've just rounded those off. All right, so 2 different ways that we can look at our exponential function. We have an increasing and a decreasing. So if y equals a to the x and a is a number greater than 1, that is going to be an increasing function. So to get an idea of what that looks like, let's make an xy chart for 2 to the x. All right, so if I put in 1, 2 to the 1 is 2, 2 squared is 4, 2 to the 0 is 1, 2 to the negative 1 means move across the division bar, right? So 2 to the negative 1 is 1/2, and 2 to the negative 2 is 1/4. So if I plot those points and I connect them, I have a pretty good idea of what's going on the top, but I'm not really sure, like, does this keep going across the x-axis or what does it do? So if I plug in a few more values, you can see that it doesn't matter how small that x value gets, negative 100, this is not going to go negative. It's going to remain positive. It's just going to get smaller and smaller and smaller. So my graph is approaching the x-axis and getting closer and closer to it, but not touching it. What do we call that? Well, that's an asymptote, and that leads us to the 2 landmarks that we are going to use for our exponential functions. First, you'll notice that we have the y-intercept at 1. So unless you've had like a reflection or a shift or a stretch or shrink, your y-intercept for that base function is always going to be 1. And then, as we just noted, we have a horizontal asymptote at y equals 0. So how that helps us is, if we want to graph y is equal to 4 to the x, I automatically know I have a y-intercept and I have an asymptote. So I know what this piece of the graph is going to look like. All I need to do is figure out this piece, and I would only need 1 point to do that. So I'm going to come over here and plug in 1 for x, and when I plug in 1 for x, I get 4, and that tells me how steep to make it. So now I'll be able to graph an exponential function with just 1 point. All right, if instead of it being 2 to the x, if it's 2 to the negative x, or you could think of that as 1/2 to the x, so you can think of your a value being between 0 and 1, or you can think of it as a negative exponent. In either case, that is going to be our decreasing function. So again, I'll start with just making an XY chart for 1/2 to the x and plotting those points, and this is what I get. And so when I connect those points, I see that same kind of shape that we saw a moment ago with the increasing one, only this one is going down, it's decreasing. Notice that we have the same two landmarks. We still have the y-intercept at 1. We still have the horizontal asymptote at 0. So if I want to graph 4 to the negative x, or 1/4 to the x, I'll already know that I have the horizontal asymptote, that I have the y-intercept, and that I have a decreasing function. So I know what this piece of the graph looks like. I just need to plot one point over here. So I'm going to plug in -1. And when I do, 1/4 to the -1 is a +4. So I would have -1, +4, and that would tell me how steep to make my graph. All right, let's think about domain and range. For the increasing exponential function, what's your domain? Well, it's going to be all real numbers because this keeps going infinitely in both directions. Our range is not, though, because if you notice, we're not using any y values down here. As we come up, the first y value that we're approaching is 0, and then we go to infinity. So our range is going to be from 0 to infinity, and remember, we have to put a parenthesis with that 0 because we can't be equal to it because of the asymptote there. And of course, we always put a parenthesis with infinity or negative infinity. All right, how about the decreasing function? What about its domain and range? It's going to be exactly the same. All right, additionally, we've talked about the decreasing function, we've talked about the increasing function. There is one special case of the increasing function called the natural exponential function. E is a number kind of like pi. It's non-repeating, non-terminating, and so we assign it a symbol to make it easier to work with. So this would literally be y equals 2.718 to the x. So for the increasing function, a has to be a number greater than 1, right? 2.718 is greater than 1. So you'll notice that graph looks exactly the same, has the same y-intercept, has the same horizontal asymptote, has the same domain and range. That's our natural exponential function. In our next video, we're going to do a review of logarithmic functions and their graphs.